Okay, so in this angle of elevation problem, we're told that a research ship finds that the angle of elevation of a volcanic island peak is 25.6 degrees. However, when the ship moved 1,050 meters closer to the island, the angle of elevation is 31.2 degrees. What is the height of the peak above sea level? So if we think about what's happening in this problem, right, there's this peak, this volcano, right, this is a volcano right here. And right here is the top of the volcano or the peak. And let's say this is the sea level right here, right? So in the water, there's this ship, and it's further away at some point, right? But the ship is, let's say it's here. Well, the angle of elevation from the ship to the peak when it starts is 25.6 degrees, right? And we know that it moves some distance. It says here, sorry, it moves 1,050 meters, so we know that it moves 1,050 meters from, let's say, point A to point B, and we know this distance is 1,050 meters. And what we know that then is that at this new distance, when the ship looks up from, let's say, point B, right, it's closer to the volcano, so it has a steeper angle of elevation, right? The idea, let me change colors there. The idea is that the closer you move to the volcano, the further up you have to look to see the top of it, right? Think of any building. If you are walking closer and closer to the building, right? In fact, when you're right next to the building, or in this case, let's say at the base of the volcano, let's say you're standing right here, you'll be looking straight up to see the peak, right, at a 90-degree angle. So it is logical that as you move closer and closer to your volcano, you will be looking higher and higher up to see it. Now we're trying to figure out, from this limited amount of information, how high is this volcano peak up here, right? And what's interesting is that, to solve this, what we can do is combine some of our ideas in trigonometry with some algebra. Because if we look back at our original measurement, right, let's say this is the right triangle that we start with. And, when this ship is beginning at point A. Here we know we have an angle of elevation of 25.6 degrees. So let's call that triangle A, since it's when the boat is starting at point A. So for that triangle, we're going to use the tangent ratio because we want to know x, the height, right? Let's call h the height, sorry. And we know that this entire side here is some distance x, is the adjacent side on the triangle. So we can use tangent there to solve it. And this is for A, for triangle A, we know that the tangent of 25.6 degrees, right, tangent is opposite over adjacent, so it's the height over the adjacent, right? And if we want to find the height, which is our goal, we're going to multiply both sides by A. Remember that the tangent of 25.6 degrees is just some number, so we can multiply it by A. That's our adjacent side, A. So here, A over A cancels out, and what do we get is we get A times the tangent of 25.6 degrees equals H. And when we look at triangle B, right, this is our second equation now. We have triangle B. Triangle B, well, we know that, again, the tangent this time of 31.2 degrees, right, that's going to equal what? Again, it's going to equal the height. But this time, how can we define the adjacent? Well, we know that whatever the adjacent was before, right, now it's 1,050 meters less than it was before. So I'm going to define this new side as adjacent minus 1,050. I'm just, my thinking is going back to this side up here. First, we had this entire length in triangle A. If you subtract the distance between A and B, you will get this new adjacent side here. So if I scroll up, right, here, this triangle, this length right here, that's the full adjacent side we had before, minus 1050, right? And this actually, if we just manipulate this a little bit, we'll be able to solve it. Because now we want to solve for h again. And this time we're going to multiply by a minus 1050. That'll cancel, these will cancel out right here. And if I multiply it on this side, I ran out of room, right? What do we get? Well, we can actually distribute the tangent of 31.2 degrees because we have a minus 1050 times the tangent of 31.2 degrees, and that will equal h. And we're going to distribute because, right, we know in both cases we're solving for the same height. And in one case, the height equals a times the tangent of 25.6. In the other case, it equals the tangent of 31.2 times a minus 1050. And essentially, we're trying to find a height, right, where these two things are equal. So what height will have equivalence between a times the tangent of 25.6 and a minus 1050 times the tangent of 31.2? Well, to find that out, we use our algebra. So we have a times tan of 25.6 equals, and here I'll distribute the tangent of 31.2 to both a and 1050. So we get a times the tangent of 31.2 minus 1050 times the tangent of 31.2. And here, essentially, what are we solving for? We're going to solve for a, right? Because we want to know the distance of the adjacent side. And once we have that, we can solve for h. Well, here it might not be clear at first, but remember what we're dealing with, right? When we have a times the tangent of 31.2 and a times the tangent of 25.6, we can add these two terms. They're like terms because these tangent values are just numbers. So if I had a similar equation, if I just had, let's say I had with the a variable a times 2 equals a times a different number, because these numbers are different, times 5 minus, and here we have the product of two numbers, let's say 3 times 4. What would you do to solve for a here? Well, with any type of algebra problem like this, I would subtract, right, the a term over to the left to get my variables to the left. And here, these cancel out. 2a's minus 5a's is negative 3a. In this case, I would equal negative 12. We'd solve for a, divide both sides by negative 3, right? And what would happen? Well, here a would equal 4. Well, all of these steps are similar to what we're going to do here in solving this problem. It still looks a lot more intimidating because we're dealing with these tangent values. Remember, after all, tangent values are just numbers. So again, I'm going to subtract a times the tangent of 31.2 from both sides. And here, what's going to happen? Well, on the right-hand side, they cancel out here, and we get negative 1050 tangent of 31.2 equals here a times the tangent of 25.6 minus a times the tangent of 31.2. And we want to solve for a, right? So at this point, I'm going to find the tangent values, because if I factor a out, it's going to be the tangent of 25.6 minus the tangent of 31.2 times a equals negative 1050 tangent of 31.2. All I did there is factor the a term out of these two terms right here. What does that mean? Well, if I had, for example, a times 3 minus a times 2, that equals a times 3 minus 2, right? Factor the a out, which also equals 3 minus 2 times a. Just reversing these two things here. And so here, that's kind of what I have, the difference of these two numbers times a, and that's just factoring out, right? So what does this allow me to do? Well, I don't want to find the tangent values yet because they're going to be really nasty looking decimals and I have to carry them in the calculator. So here I'm going to divide both sides by this number. It's a number, whatever it is. It is a number. We divide by this number on both sides. It's going to cancel out on the left, right? Any number divided by itself is 1. And now we have everything we need to get the answer because we know A equals this. So now we can evaluate all this in our calculator. We have negative 1050 times the tangent of 31.2. We get a negative value. And then we would subtract these two tangent values down here. So I'm going to divide this result by the tangent of 25.6, close parentheses, minus the tangent of 31.2, right? Close those parentheses, and we get our answer here, 5026.8263. So A equals 5026.8263. Okay, what does all this mean? This means our original adjacent distance, right? The distance from the boat. Let me scroll up here. Oops. The distance from the boat, from here to the base of the volcano is that distance. So the angle is 25.6 degrees, right? So we can use our angle of elevation here. Sorry about the zooming here. With this original adjacent distance. Now, going back to basic angle of elevation, right? We're starting here at this point. Let me change colors there. This is where we're at. We just travel over 5,026.8263. I believe this is meters. And we have our angle of elevation here. And now we can just find this height right here, h. So again, the tangent of 25.6 equals opposite, which is height, over adjacent, 5,026.8263. To find h, we multiply both sides by 5,026.8263. So the tangent of 25.6 times 5,026.8263 is our height. So let's finally enter that in. We have the tangent of 25.6 times 5,026.8263. Then we get a decimal here, 2,408.4516 repeating. So that's 2,408.45, and then with 16 repeating, and then it depends how you're going to round that. But that's our height. And you can plug this into either scenario to see that it actually makes sense. Whether it's the full distance away or closer with that new angle of elevation, you will get this height. Thanks.